Okay, good morning, all. Hope I'm audible to you all.
Good morning, sir. Yes, sir, you are audible.
Yeah. And the screen is also visible, seems. Okay. So, as we discussed yesterday, that we can have a process called development, and after this process, we get the photoreceptor with the image that is having the toners placed in the locations where we want to print. So that is the purpose of development. So suppose this is what is the plate after the development. So the next process called is transfer. Now, as the name says, uh, transfer means transferring this image from the photoreceptor drum or photoconductive drum to paper or any other substrate. Normally we use paper only. In some cases we use plastics, but that is very seldom we do that. Maybe we want to print some transparencies and all. But otherwise, considering the normal scenario, it is mostly the paper which is printed. So then the next process for transfer, what we have to do, we have a simple process over here that we have to take the substrate above it, and here also we have to give a bit of charges, so that it means you, as I already told, that always you have to understand that why everything is happening over here. It is basically the dynamics of charges. Now here also what we have to do now, uh, mostly, as you know, that these were the positive thing, and then this came negatively and they got attracted. Okay. Now this potential over here is generally much more than the potential in this what you call this toners, because toners were basically charged by means of static electricity. Okay. Whereas these charges which were deposited to form the latent image, they were actually not the static charges, but they were given by the corona charging principle. So the potential of this plate, which was we taken as a positive potential, is considerably higher than the negative potential over here. So basically, they are now having a polarity of positive charges. So what we have to do here, we have to now put a charging over here. Means paper cannot means you cannot charge the paper directly that way. So what you have to do, you have to make an induced field over here, and in between you are putting the paper. So, and this can also be done using the same corona thing. Okay, but may not be of that huge potential. Like, as I already told, that you need around 6 to 12 kV for charging. You may not need that much, because a slight thing will help it. Okay. So when you create this negative potential over here, what is going to happen? These toner particles, they are going to leave this surface and they are going to attach to this paper surface. Hmm. And that is how the transfer happens. Now here, in most of the cases, what happens? We don't use this gap over here. Okay. So to ensure a better transfer, what we normally do, we do it in contact. That means it is something like this. Okay. So let me draw it a bit better way. So it is having a, this is actually a easier way, because you need a lesser charge for this also. And here, to ensure a good transfer, we also use a slight amount of pressure. Okay. A very small amount of pressure is used here to ensure proper transfer. And this is one reason why we many of the times don't call electrophotography a truly non-impact printing, because this is one place where we may use a little bit of impact. Okay, where we may use a little bit of impact to ensure good transfer of these toners from this photoreceptive drum to the substrate. So after this, what happens? After this, as you can understand, that we have now the paper, and on the paper we have this substrate, sorry, the toners. But these toners, as you can understand, that they were basically transferred by means of a potential difference. And once this electrode or whatever mechanism has been taken over here, that has been taken away, that means once these charges are removed, now these toners may again go back to the photoconductive drum because they don't have any attractive force over here. So to avoid that, after transfer we have a very important process here which is called fixing. Now fixing means you are going to put these toners within the fibers of the paper. That means they are getting setted. Okay, so this is also called setting. That means transfer is done, but now you have to set them. Okay, if the setting does not work, what will happen after the paper comes out? You, if you just put it like this way vertically, you will see some of the toner particles, not some, maybe the most of the toner particles are leaving the paper and falling down. That is not what we expect. So what we do now, we use the fixing now. Now this fixing is majorly done by heat fusing. Okay. Now heat fusing, as the name says, what is going to happen, that you are going to apply a heat over here, and by that heat these toner particles are going to melt and they are going to attach to the fibers over here. Okay. And this is a very important thing, like when you will study the paper technology or ink technology, there we will read lot about it. Okay, that how the setting happens, whether it a heat setting, with heat setting is happening or cold setting is happening or UV radiation setting is happening, because this setting can be done by many of the ways, but most commonly used one is the heat setting. Okay, where we use a heating element which heat it, they melt down and they fuse. Now here two things we have to remember, that this heating should have to control, because if you overheat, then what can happen, the one thing, your paper itself can get damaged. Okay, so when we are using heat fusing, two very important things, that heat should be well controlled. Otherwise your paper itself may get, burnt. Okay, because if the heat is very high, then it can get burnt. Also there is another thing which may not be very instrumental in many of the cases, but that can also happen, as you might have known already, that paper is a very a delicate kind of material, and the moisture content of a paper is a very important thing. Okay, this is called moisture content. That means how much moisture the paper is having. Now if there is no moisture content, your paper is going to be very hard, so that becomes a kind of brittle, like it will have a brittleness, so it cannot have that flexibility for which paper is actually used. At the same point of time, if you have a huge amount of moisture, then also your paper will have a change in the dimension. Okay, because these are made of paper fibers, so if you put water into it, they are going to absorb that water and they are going to expand. Okay, and because of that expansion, you may have curl in the end of the paper. তুমি দেখবে, you may observe this, that if you keep paper a very long time open air, you will see that it changes its color, its shape, sometimes lot of degradation happens. Now when you are putting this heat, we have to also remember that this heat is not going to absorb lot of moisture from the paper itself. Otherwise what will happen, your paper will have a high brittleness and it may not have the flexibility which is needed to pass it within the machine. Like suppose in the machine your paper will, there are a lot of rollers between which your substrate or paper is going to flow, something like this maybe. So if your paper becomes very brittle, this kind of movements may not be allowed. Your paper may be come like this, then like this, so this way, because once the moisture are absorbed, your paper become very stiff. Okay, so this is another important thing. And also means if you, this is also a very, so one thing is the moisture control of the paper. And finally, this is also a very important parameters. This is also a very important parameters that, like when you are melting them, after melting, your this thing is going to get fused, and you are going to get it like this. Now, what is the spread of this molten ink? What is the spread of this? If it spreads a huge lot, say for example, you want your dots. I'm not sure whether you are already introduced to dots or not, but afterwards you will be obviously. Suppose this is what you want to print. Now, in many of the cases, have you heard? I'm not sure whether you have heard these terms called half toning or not. If not, don't worry, afterwards we are going to discuss it. But anyway, just for the time being, you understand that half toning is something which is used that where we use dots to represent different shades of color. Okay, for example, suppose you want to print something like this nature, suppose you want to print this. Okay, then following this, I'm going to print, say, this. And again, like after this, I'm going to print this. So in this case, you can understand that there are three shades. Okay, normally we call them gray shades because we don't have any color. These are the shades of the gray. But suppose when you are going to print it, now if you want to print, you need three inks. One is black color, one is this gray, one is this gray. But that is not possible, because if afterwards you may understand that why it is. So, or say for example, you have already know the screen printing. So you have to make one screen for this color, one screen for this color, one screen for this color. Now I have taken only three colors. In actual reproduction, you can understand that there are millions of colors. Now, how can you reproduce so many? Because suppose you have hundreds such shades, so is it at all a practical proposition that you use 100 screen or 100 like that? It is not possible, right? So to accommodate this kind of variation, we use a technique called half toning. Okay, this is basically an illusion to human eyes. Okay, which looks like that you have the different shades, but basically you are using a single color. Just to give you a better insight, this may help you. Suppose this is a grid. Okay, now if this grid, if you see from very close, you can understand that it is appearing like this. Now suppose I am filling few of these grids. Okay, suppose I fill, and this one I fill like this. So when you are seeing from a distance, what you are going to see? Any guess from your side? If you see these two figures from a distance, say of distance of 1 feet or 2 feet, then what are you going to see actually? And just think that grids are so small you cannot generally identify by naked eyes. So can you guess like what are you going to see? Yes, Pinky is telling 10. No, don't tell me the values and all. Just tell that means physically what are you going to see? Are you going to see a darker shade or a lighted shade? This will be a darker shade or a lighted shade. Left one. No, it's not only the black portion. No, 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 no. You may be saying that because here the grids are very visible, but in actual case the grids are not that visible, so that is why you cannot see the grids. Basically what is going to happen means when you see from a distance, this will look to you as a gray shade. Okay, because it's not totally black. Obviously this is going to appear as totally black, but if you take away few of them, so from a distance they won't look as a totally black, but a very dark gray shade it will appear as. Similarly, this will also appear a gray shade, but not as dark as this. Okay. So in this way, fundamentally using a single color, using this kind of gridded representation, which more technically called dots, we represent the different shades of color. Using only one color ink, we can represent different shades by using the technique. This is called half toning. Now, when you are doing this half toning, and if this spread of the ink, this is called the spread of the ink, is very high, then what is going to happen? You cannot have these gaps. Okay, you cannot have these gaps. So, if you don't have the gaps and if these white spaces are not present, basically everything will look as black to you. Okay, these gaps are very important over here, these white areas. Okay, now that is why I told that heating is so important, that these toner particles are not spread it across and they are just like mixing with each other, so you cannot have the gap. For example, if you want to print A, these portions must be left blank, but instead of that, due to this melting of the ink, if it appears like this, then it will appear like this. So this is not what we expect. Okay, so that is why this heating, the fusing process, the heat control is very important. We have different heating elements for that. Mostly they are electronic heating elements made of resistors and made um, of very high resistance, which is going to get produce heat if you means put that in a circuit, and if current going to pass from it, so it will develop the heat. So those are called the heating elements, and that's how we fix it. And that is why you will see normally a Xerox copy when it comes out, or a laser printer when it comes out, it is a very means it is a hot thing. Okay, and that is why many of the times this is called hot sheet. Because in the laser printer xerography, due to this fusing process, the fixing process, the it is a good amount of heat which is produced over here, and for that reason you will see that some heat. And sometimes also, if the printer is very old, you may see a little amount of smokes and all also there. May not be very huge amount, but a kind of wave you can see there. Okay, so that is the reason why it happens, due to this fusing process. Okay, that's all for the xerographic, the electrophotography, although there are many physics wise and chemistry wise details, but since our scope is not that elaborate in this particular topic, I'm not going into that. So fundamentally what we understood, that what are the major processes included in printing. However, I have not told a very important thing. So that is also very important that I actually missed, but we should not miss that. That once this printing happens, it is a very important step which is called cleaning. Cleaning. What is the meaning of cleaning? Cleaning means that once the the, as I already told, that this is the thing. So suppose you have printed, but many of the times it can be the case that after printing there are some residual potentials and charges on the plate. Okay, so it, because some of the charges may not be well, developed. So these are called residual charges. Rather, it is also called residual potential, because after the development and this transfer happens, ideally your potential on this plate will be equal to 0, because all the charges either have discharged during exposure, or it has been already used for the development process. But this does not happen in practical cases. There is always a residual potential over here. Now this can be a very big problem for the next image. Suppose first time you wanted to print this thing. You have to print two things. This is the first work you want to print, and this is the next job you want to print. Okay. Now what is going to happen in the first case? You had the plate something like this. This is what your plate should have been, and they have got transferred. But after transfer, this is remaining over here. Suppose this one is remaining. So when you do the next one, then what is going to happen? For the next job, your toners must have this kind of arrangement, but this is the residual toner. Or maybe you had a residual charge over here. So what is going to happen here also? Some toners may get attached. And this is going to cause a problem. Instead of this is what is required for the next job, but you may end up getting a result like this. And these two which is got printed, they are not actually a part of this job, but they are the residual part of the previous job that is done. To avoid such circumstances, we use the cleaning process. Cleaning process is very simple over here. There are many cleaning processes. One is there is a very soft brush, and since as I already told that these charges or the toners, they are very weakly attached. As all the charge movement have already happened, they don't have that much attractive force that they are very tightly attached to it. So if with a small, if with a soft brush, if it is just wiped few times, then due to the static electricity, these charges goes and these toners get collected, and whatever are the residual charges, they get, you know uh, neutralized. So this is one of the simple most process, and many of the times in earlier days it was very well seen. Nowadays we don't see. In Xerox machines you might have seen that many of the times they bring out the drum outside, and they with a very small a very soft cloth, they just rub it few times. Okay, that also helps, but this is not a very advised way though. In modern technologies, what happens, like they again have a development electrode, which was earlier told that here also it helps, but in that case the development electrode is not charged with a DC supply, rather an AC supply. Now how it helps, suppose you want to put the positive charges when you are charging, then it will have the positive thing. But in this case, to neutralize the plate, you may use the polarity of the opposite polarity. That means if your remaining charges are positive, you can use a negative polarity over here. So this kind of charge dynamics, by using the development electrode, it can happen. However, there is one catch over here, that after a uh, certain time, that means maybe year, means using for 2 3 years or maybe 5 years, depending on the quality of your machine, there are few small cracks, wears, this kind of things appear on the plate. So your photoreceptive coating itself get degraded a bit. These are the called the trap. These are the traps where the charges get accumulated, and you cannot bring out those charges very easily, since they are very well trapped in the in the photoconductive drum itself, or photoconductive layer itself. So that is why they are quite well settled over there, and this you cannot do. That's why you will see the old machines, you will have lots of unwanted spots, but a new machine that gives you comparatively lesser this thing. Okay, at the same point of time, it sometimes again happen that in the laser printer, although this happen for the inkjet also, you will see that if you used refilling of your cartridge, okay, there also this kind of things happen. Now, the main reason of that is not actually related to photoconductor, but there also you may see some faded bars of colors are coming. Mean basically the ink is coming in unwanted areas. Now, this can happen due to one reason, that is it is not cleaned, your photoreceptor drum is not cleaned. This can also happen due to the ink itself. That's why many of the times we uh, don't prefer to use refilled ink. Okay, uh, because one reason is that everything, the entire process, if you think that, you can understand one thing, that it is a very highly synchronous process. There are lots of rollers, lots of cylinders, they are actually moving in a very synchronized way. Okay, but the problem is that if any of the material is having a different characteristics, then this entire thing can get disturbed. Say for example that you have developed the system such that an ink will be used, and within 2 seconds the entire ink will transfer from this roller to this roller. But how fast the ink transfer, or how fast the ink move from one cylinder to another cylinder, that depends on many of the characteristics of the ink, especially the rheological property, what we call the rheological property. For example, the viscosity, the tack, and all these things. So if the rheology of the ink changes, then your entire system may get hampered. Okay, so that is why in refilling, you many of the cases you not only get poor quality print, but also it causes damage to your printer itself. Okay, but anyway, as for the economical reasons, we use it. Uh, so the last thing for this discussion on photoelectricity, and as well as for today's class, I'm not going to the next topic today. Like this is a very important characteristic curves for photoelectricity. This is called PIDC. PIDC curve. This means photo induced discharge curve. Okay, and here what we have the potential over here, potential over here in this range, and here what we have the time. That means the entire processing time. And this curve is having a nature of something like this. Okay, now it is having different segment. So this is what, okay, this is the initial stage. That means it is in dark stage. Okay, this entire process, sorry, this stage is happening in the dark phase. That means you are not putting any light on the photoconductor. Okay, and this is the process of charging. Means after till charging process, this is the potential graph, and this is the portion which happens in the exposure stage. That means here we subject or we expose the plate with light. Okay, and this is the process of exposure. Now as you can understand that we have a small toe over here. We have a start. It is actually, theoretically this should start from zero, but it never starts from zero. It is always having a residual potential over there. So it starts like this, and during the charging what happens, it accumulates charge slowly, and after some point of time it comes to a stable thing. Okay, and this is the maximum potential you can do. After that, if you keep on charging also, it is not going to use it. Okay, so this is the highest potential, or we can also call in very general way, we can call that this is a charge saturation limit. Okay, so this is the highest potential, or you can also say this is a charge saturation limit. After that, if you keep on charging, then also the potential of the plate is not going to change. And after that, when it is exposure, here there is one simple thing you need to mention. It is not very clearly visible over here, that before the exposure happens, because charging stops, exposure happens, there is a very small time gap, maybe in millisecond term, but it is there. And due to this time, what happens, actually in the dark, as I told, that your photoconductive drum is actually going to work as a battery or as a parallel plate capacitor. Okay, that means it is going to, গোদা বাংলায় বলতে গেলে এটা চার্জকে ধরে রাখবে, কিছু করবে না, যেমন তুমি চার্জ করেছো সেরকম ভাবে ধরে রাখবে, বাট দ্যাট ডাজ নট হ্যাপেন। ওকে, So in this case, you have a very small discharge happens. That means the potential falls a bit, although it is in dark. Okay, so I will tell that this is the dark phase. That means you have not exposed it. This is called dark decay. Dark decay. That means, say for example, you have gone that okay, the potential should be something like 5 volt. I'm just giving a very rough example. So when you starting the exposure, you know that there are 5 volts, so I have to decrease it. But you may see it's not exactly 5 volt, it may be 4 point say 89 volt. This potential drop is called the dark decay. So if your component of or your plate is having a huge dark decay, then we have to be very cautious about it, because see, the moment the potential is not as expected, your entire calculation of how long you are going to expose, how much you are going to expose, what should be the lux of the light with which you are exposing, every parameter is going to change. Okay, and finally, the exposure here happens. As you can understand, the potential start dropping because the charges are getting discharged. So it, but ideally it should come to zero, but that never happens. So this potential is what I already called. This is called residual potential. And this thing, what happens, as you can understand, if you are not charging also, there are a small amount of potential which is remaining. This happens due to fatigue. That means after long time usage of the photoconductive drum, there are some wears and tears that are inevitable in any photoconductive drum or photoreceptive material for a long use. Okay, and for that reason, there are some small cracks, holes created in the photoconductive drum, which changes the surface characteristics, which in turn causes some trapping of the charges. And due to this charge trapping, this fatigue happens, and some of the potential always remain on the plate. That is called the initial potential, you can say, but the reason is basically the fatigue of the plate. So this is what is called a PIDC, which is a very important characteristics, and any in the technical data sheet of the laser printer or Xerox machines, they always provide this PIDC, that what is the PIDC characteristics of this particular machine's photoconductor. Okay, so that's also we have seen the most of almost all the process steps. However, we have not gone into much detail about the physics and uh, chemistry behind it. But anyway, we have seen that how the charging happens, and then we saw how the exposure happens, and then we have saw how the development happens. Then we saw how the transfer happens. Finally, we have fixing, and the last stage is called the cleaning. Okay, so these are the major steps of electrophotography or xerography, or laser printing also work in the same principle. So with that, we end the first thing of our thing, that electrophotography. From next day, we will start the inkjet printing. And if you have any doubts in between about today's class, you can ask me.